Hello everyone. Today we are going to learn about shortest remaining time first CPU scheduling algorithm. Welcome to this presentation on SRTF scheduling algorithm. We'll explore its definition, functionality, advantages, disadvantages, and one of the example of it. So let's start. What is CPU scheduling? First we should learn this. CPU scheduling is a crucial operating system function that allocates processor time to various processes to optimize performance and resource utilization. It aims to maximize CPU efficiency, reduces response time, and ensure fair access for all tasks. Among different algorithms, shortest remaining time first is a preemptive scheduling method focusing on minimizing waiting time by dynamically selecting the process with the shortest remaining burst time. Understanding SRTF provides insights into how advanced scheduler balances responsiveness and efficiency. Shortest remaining time first scheduling. Shortest remaining time first scheduling is a preemptive scheduling algorithm used in an operating system to manage CPU tasks efficiently. It works by allocating CPU to the process with the smallest amount of remaining burst time, ensuring optimal process handling. The algorithm is designed to minimize the average waiting time of the processes in the ready queue, making it effective for enhancing system responsiveness. SRT finds applications in real-world CPU management scenarios where tasks must be handled swiftly, prioritizing shortest job while allowing preemption if a shorter process arrives. Core concepts of SRTF: preemptive shortest job first, smallest remaining time allocations, trigger for scheduling decisions, requirements of CPU prediction. Most of the importance is preemptive shortage job first. SRTF is the preemptive counterpart of the shortage job first algorithm, which assigns CPU to the shortest job currently available. Then, requirement of CPU bus prediction. SRTF require advanced knowledge of each process's CPU's burst time, which can be practical limitations. Now move to its next slide, or algorithm of the steps. SRTF algorithm steps. First step. Each incoming process is added to the ready queue immediately upon arrival. Then second step. Sorting by remaining time. The ready queue is dynamically sorted based on the remaining burst time of process, prioritizing the shortest one. Then preemption check. If a new process arrives with a shorter burst time than the currently running process, the CPU is preempted in favor of the new process. Then completion. The cycle continues until all processes have fully executed and exited the ready queue. Now let's take an example of it. First, we have four processes, their arrival time, their burst time. Process 1 has 0 arrival time with burst time 5. P2 has 1 and 3, P3 has 2, 4, P4 has 4 and 1. Now let's take a glance of its Gantt chart. As we can see, P1 arrives first as its arrival time is 0. Then we can see P2 as its arrival time is 1 and burst time is 3. So it will run and complete. Then P4 will come as its burst time is 1. Then P1 will complete its cycle as its burst time is 4. Then P3 will come. As we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 13 are the time taken for the completions. Remember this. Uh, then calculations. Completion time, turnaround time, waiting time. So here we can see process 1 takes 9 milliseconds we can say for completion. P2 take 4, P3 take 13 and P4 take 5. Turnaround time. Turnaround time is basically completion time minus arrival time. So we can see 9 or P1 process arrival time of 0. So completion time will be 9. So 9 minus 0 will be 9. P2 has arrival time of 1. So 4 minus 1 will be 3. Completion time is of P3 is 13, then 13 minus 3 will be 11, 5 minus 4 will be 1. So waiting time is this. And their average waiting time here will be 6.75 something, I guess. And turnaround time will be 6. So now move to its next slide. Advantages of SRTF. Minimizing average waiting time, optimal throughput, and effective in batch processing. Minimizing average waiting time is mostly most important advantage of SRTF. because it minimizes the average time processes wait, enhancing overall system responsiveness. That means it enhance overall system responsiveness as it has a great speed and shorter remaining time first. So now move to its next advantage, optimal throughput. By prioritizing shorter job, SRTF maximizes the number of process completed over time. Then effective batch processing. Disadvantages are also there of SRTF. SRTF is impractical in real life system. It only be practical on like written in books or because burst times we cannot know the burst time beforehand in the often processes. Starvation risk. Longer process might suffer indefinite delays if smaller tasks continuously arrive. Higher context of switching overhead. Frequently, preemption can lead to sustainable time loss when context switching. SRTF versus other scheduling algorithms. First come, first serve, round robin, priority scheduling. Let's see for first come, first serve. Simply simple and fair, but can cause high waiting times, especially if long jobs arrive first. That means if a long job arrives, so the waiting time will be the high for first come, first serve, then round robin. Offer equitable time slice but increase context switching overhead unlike SRTF. Then priority scheduling. SRTF dynamically assigns priority based on remaining time, leading to more efficient scheduling than priority scheduling. Performance analysis. Average waiting time typically minimal compared to other algorithms due to prioritization of shortest remaining processes. Throughput can be high, but heavily depends on process arrival patterns and burst time distribution. Context switches. Potentially higher overhead due to frequent preemptions impacting CPU utilization. Then starvation risk. Longer process, the longer they suffer. When to use SRTF? Firstly, we have to know its burst time, interactive system, low process arrival frequency. SRTF excels when process burst duration of known beforehand or can be accurate estimated. Interactive systems, ideal for systems requiring quick response time, such as interactive or real-time applications. Low process arrival frequency works best when process arrival are spaced out, reducing frequent preemptions. Key features of SRTF: preemptive scheduling, dynamic decision making, minimizing waiting time, and starvation potential. Here is the pseudocode of SRTF. You can use wherever you want it. It is the best I can get or I have written. Then context switching overhead. I don't think this real world analogy. Imagine a supermarket checkout choosing the customer with the fewest item list in the cart for serve next. The minimize overweight for quickly clearing small orders, representing how SRTF frames longer tasks for shorter ones. So basically, here we are seeing the real time examples. Then once there is a myth of SRTF that SRTF is always better. This is a common misconception. Overlooked scenarios when burst times are unknowingly high variable. Reality only when burst time is known, then no starvation occurs. So here we are on conclusion. First, effective minimization, less practical and ideal use. SRTF minimize waiting time when burst time is unknown. Less practical because we have to know its first time first and it's not possible. Ideal is thank you. Thank you for listening to me and I hope you really enjoyed it and learned something good. Thank you.